about the associative property and how to use that as a strategy when we're doing our multiplication facts. This is a strategy that will help us. Now, before we get into our review activities and learning a little bit more about the associative property, let's first go over our I will statements. Remember, these are things that by the end of our lesson, you will learn a little bit more about and be able to help turn these statements from I will to I can statements over time. I will read the statement first. The second time I read the statement through, read it on the screen with me and say it aloud as a class. Listen first. I will define the associative property. I will define the associative property. Nice job. Make sure I can hear you with this next one. I will use the associative property when solving multiplication problems. I will use the associative property when solving multiplication problems. These are our two main goals throughout today's lesson. Before we get into it, let's go over a few review activities. For this first activity, you are going to help me solve some different math equations looking specifically at parentheses. Let's look at the first problem here. Remember, when we have parentheses in a problem, that means we need to start with the parentheses before going to anything else. Let's look at A first. The parentheses are around 6 plus 4. Let's do that first. What's 6 plus 4? Good. 6 plus 4 is 10. So I'm going to rewrite that as 7 plus 10. Remember, the plus 7 was there. We didn't use it yet because it wasn't inside the parentheses. What's left in our problem is 7 plus 10. What's 7 plus 10? Shout it out in 3, 2, 1. 17. Nicely done. Now let's look at the same problem. It has the same factors in it. But the parentheses are now around 7 plus 6. So let's start with 7 plus 6. What is 7 plus 6? Good. 7 plus 6 is 13. I'm going to rewrite 7 plus 6 is 13. And we leave the plus 4 because we haven't used it yet. What's 13 plus 4? Everybody shout it out in 3, 2, 1. It's 17. Give me a thumbs up if these two answers match each other. We should see all thumbs up across the room because both of these were 17. The addition problems, no matter where we put the parentheses, if it's straight addition across, it still gives us the same answer. Let's see what happens with a multiplication problem and parentheses in those. Let's start with our top problem. I'll erase these up here. Our top problem says 3 times 2, that's in parentheses, times 4. We have to start with what's inside our parentheses. Everybody, on your fingers, hold it up. What's 3 times 2? Good. 3 times 2 is 6. So I'm going to rewrite that as 6, and I leave our times 4 because we haven't used that yet. Everybody whisper, what's 6 times 4? 24. Nicely done. I hope you used your whisper voice. Let's see if the same multiplication problem, it has the same factors we used in the above one, changes if we put our parentheses around the 2 times 4 instead. Let's start with 2 times 4 because it's in our parentheses. Everybody shout out, what's 2 times 4? Good, 8. 2 times 4 is 8. I'll write it beneath this time. Let's bring down the 3 times because we haven't used it yet. What's 3 times 8? What does that give us? 3 times 8. Shout it out in 3, 2, 1. 24. Nicely done. Give me 2 big thumbs up and a silly face if we got the same answer for both of these problems. Although our parentheses were in a different place, I should see a double thumbs up across the room because these are both 24. Although our parentheses were in different places in the problem, because these are straight multiplication, straight across, and there is not more than 2 factors in here, our answer will always be the same. Now, what happens if we change it and we have more than one operation in our problem? We just did an all addition problem and changed the position of the parentheses, and an all multiplication problem. Let's see what happens when we use 2 operations. For these 2 problems, we have an addition and a multiplication operation in each of them. Let's see if we get the same answer like we did in the other problems. Let's start with A. Remember, where do we need to start? Inside the parentheses. Whenever you see parentheses in a math problem, you need to start with what's inside of them. It's like a present. The important stuff's going to be right inside here. Let's start with 3 plus 2. Everybody shout out. What's 3 plus 2? Good. 3 plus 2 is 5. I'm going to rewrite that. Here, I'll put our problem up here so we don't forget. We started with 3 plus 2 times 5. Still have the times 5 down here, but we simplified it a little bit. Now let's solve it. What's 5 times 5? Everybody say it in your funniest accent. Ready? 3, 2, 1. 25. Good. 25. 5 times 5 is 25. Let's see if we have the same problem with the same numbers, but we just moved the parentheses over. Now we're going to start with our multiplication problem. I'm going to put a little line between these to help us. What's 2 times 5? Hold it up on your fingers in 3, 2, 1. Good. 2 times 5 is 10. Now we use everything inside the parentheses, but we need to bring down what we didn't use yet. 3 plus. Now let's solve this problem. What's 3 plus 10? Everybody shout it out in 3, 2, 1. 13. Nicely done. Now, when I look at these 2 answers, are they the same? Give me a thumbs up or a thumbs down. No, these aren't the same answer. When you have a problem with parentheses, if there's different operations that you are using and more than 2 factors, then your answers are going to differ depending on where the parentheses are. Before in our problems, when they were all addition or all multiplication, it didn't matter where the parentheses were. We still got the same number going across. Make sure to pay attention to those parentheses. They're always important in a problem and telling us where to start. Let's use that knowledge of our movement of the parentheses to help us solve a problem like this. 16 times 3. Now, a double-digit number is scary can be scary when it comes to multiplication because off the top of my head, I might not know what 16 times 3 is. Let's break 16 down into smaller numbers. What numbers can I break 16 down, or what numbers can I multiply together to get 16? I know I can do 4 times 4 to get 16. What else could I do to get 16? Somebody raise their hand and chat and say it for us. Did you say we can also do 8 times 2 to get 16? If so, you're right. 8 and 2 are a little bit friendlier when multiplying instead of doing 16 in a problem. Let's rewrite our problem. We'll put 8 and 2 times 2 in parentheses because that was first, times 3 because that's what's left over on the side. Now, even if we were to solve this problem, our parentheses tell us here to do 8 times 2 first, and that just gives us 16 times 3 again. It's still a tricky problem to solve. But in our previous exercise, we saw that it doesn't matter if we move our parentheses if we have the same operation being used. If we look inside here, I see multiplication and multiplication. Let's see if we move our parentheses instead of doing 8 times 2 first. Let's do 2 times 3 first. What's 2 times 3? Good. 2 times 3 is 6. Now we have to bring down what we didn't use. 8 times 6 is one of our math facts that we have been studying. 8 times 6 is 48. It's a lot easier for us to move the parentheses over since the operations are both multiplication to solve this problem. 8 times 6 is 48, or 16 times 3 is 48. Let's try this with the other numbers we can break 16 down into. We also talked about breaking 16 down into 4 times 4. Let's see if this also gives us 48. Remember, that was the answer we just got. If we have 4 times 4 here, we'll put it in our parentheses, times 3. If we followed it like it is now and did what's in our parentheses first, we would just get 16 times 3. We'd get what we started with. But instead, what should we do with our parentheses? First, let's check. Do we have the same operation here? Are these both multiplication symbols? Give me a thumbs up if you see both multiplication symbols here. I see 2 multiplication symbols, which tells me I can move my parentheses. There's no other operations. It's just multiplication. Let's move these over. Let's do 4 times 3. 4 times 3 is 12. Let's bring down what we didn't use. 4 times 12. Now, this is still hard for us to solve. If we were to draw this array out, we would draw 4 patches of 12 dots. And then if we counted all of these dots up, we would see how many we had in total. This is an array. Remember, an array is a picture that shows us a multiplication problem represented. Here we have our 4 groups, and in each group is 12 dots. If we looked inside, we have our 4 times 3 that we started with. And we can see that we're doing our 4 times 3. 1, 2, 3, 4 times. There's our problem written out again. If we counted up all of these dots, we would get 48. When solving our array here, there are different things we can do, like counting up or adding repeatedly 12 plus 12 plus 12 plus 12 to get 48. But we can see that breaking down our bigger number and switching the parentheses around, it doesn't always work or make the problem easier. Sometimes you have to be careful with which numbers you pick. We had much better luck when we broke our 16 down into 8 times 2 compared to 4 times 4. Sometimes you might have to try more than one pair of numbers before you find the right pair that helps you simplify the problem. In this case, we got lucky the first time when we did 8 times 2 and we got 48. That was a lot simpler when we simplified. In this problem, we still ended up with a big number, and that was difficult for some of us to add, so we could switch it around and break 16 down into different numbers. You are going to continue to practice this with your teacher. Get out your whiteboards and markers, and good luck, mathematicians. You guys got this.